Hey everyone, and welcome. Today we're going to dive into one of the most crucial concepts in Java, methods. Trust me, these are the secret to writing code that's not just working, but is actually clean, efficient, and a whole lot smarter.
So, does this look familiar? You find yourself just copying and pasting the same chunk of code into different spots in your program? Yeah, it's a super common headache, but it's exactly the problem we are going to solve today.
So here's what's on deck for today. We're going to start with the absolute basics, what methods even are. Then we'll build on that with some powerful stuff like overloading, a neat shortcut called VarArgs, and even the slightly mind-bending concept of recursion before we wrap it all up.
Okay, first things first. Before we can get to any of the fancy stuff, we really need to get the groundwork right. So let's break down what methods are and why they are the absolute building blocks of any decent program.
So what is a method, really? Well, you can think of it as just a block of code that does one specific thing. The best analogy is a recipe in a cookbook. You write the recipe for a chocolate cake just once. Then anytime you want a chocolate cake, you just follow that recipe. You don't have to figure it all out from scratch every single time.
Okay, so why should you even bother with methods? Well, the benefits are huge. For starters, you're following a core programming principle. Don't repeat yourself. It also lets you break down these huge, complex problems into smaller, more manageable pieces. And this makes your code not just reusable, but way easier to read. And maybe most importantly, it makes debugging so much simpler when things inevitably go wrong. All right, let's take a look at the anatomy of a method, piece by piece. First up, you've got the return type. That's what the method gives back when it's done. Then there's the method name, which is, what you call it. The parameters are the inputs, the ingredients your method needs to do its job. And finally, the method body. That's where all the action happens.
Okay, with that foundation solid, let's get into something really cool that makes our methods way more flexible and our code feel more natural. We're talking about method overloading.
So method overloading is basically this. You can have multiple methods with the exact same name in the same class. Now you might be asking, how does Java not get totally confused? Well, the secret is that they have to have different parameter lists. That could mean a different number of parameters or just different types. It lets you use one simple logical name, like add, for a bunch of different scenarios.
Check this out. It's a perfect example. We have two methods, both named add. The first one takes 2 integers, but the second one takes 3. When you call add in your code, Java just looks at how many numbers you gave it and calls the right version. It's simple, it's clean, it just makes sense.
And you can also overload by changing the type of parameters. So here we have 2 multiply methods. One is for integers and the other is for doubles. Again, Java is smart. It sees the type of data you're using and calls the correct method. This is great because you don't have to come up with clunky names like multiply int and multiply double.
So these are the official rules of the game. You can overload if you change the parameter types or if you change the number of parameters. That's a yes. But look very closely at that last row. You cannot overload a method just by changing the return type. This is the one that trips everyone up. So burn this into your brain.
Okay, let me see that again because this is super important. Java figures out which method to use based on its signature, and a method's signature is its name plus its parameter list. The return type is not part of the signature. So if you have 2 methods with the same name and the same parameters, Java sees them as identical, and you're going to get a compile error, period.
So we've seen how overloading is great for different types or a fixed number of arguments. But what if you have no idea how many inputs your method is going to get? For that, Java gives us a pretty handy shortcut called VarArgs.
VarArgs, it's short for variable length arguments, and it is this really slick feature that gives your methods a ton of flexibility. It literally lets the method take in any number of arguments of the same type, even 0.
And the syntax couldn't be easier. You just put 3 dots after the data type, like int ... numbers. So what's actually going on under the hood? Java takes all the arguments you pass, whether it's 1 number or 100, and it bundles them up into an array for you. Then you can just loop through that array inside your method. It's just a really clean way to handle things without writing a dozen different overloaded methods.
All right, buckle up. We're about to get into a concept that is incredibly powerful, super elegant, and yes, sometimes a little bit mind-bending. Let's talk about recursion.
Recursion is when a method calls itself to solve a problem. I love the analogy of Russian nesting dolls. You open one up, and there's a slightly smaller version of the same doll inside. For recursion to actually work and not just run forever, every recursive solution absolutely needs 2 things.
A base case, that's the condition that tells it to stop, and a recursive case, which is where the method calls itself again, but with a slightly simpler problem.
A classic example you'll always see is calculating a factorial. Just look at this code. The base case is simple. If the number n is 0 or 1, we just return 1. That's our stopping point. And then you've got the recursive case. This is where the magic really happens. It returns n multiplied by the factorial of n minus 1. See? It's breaking the problem down into a smaller version of itself.
And this visual just nails it, right? It shows that chain reaction. To figure out factorial of 5, the method first has to find the result of factorial of 4. And to do that, it needs factorial of 3, and so on all the way down the line. It keeps digging deeper until it finally hits that base case, factorial of 1, which gives it a real answer to work with. This table shows you exactly how the answers get passed back up that chain. At the very bottom, factorial of 2 was just waiting for the result from factorial of 1. Once it gets that 1, it can finish its job and return 2. Now factorial of 3 has what it needs and can return 6. This process just bubbles all the way back up the call stack until the very first call, factorial of 5, can finally calculate 5 times 24 to get our final answer 120.
So, a couple of super important takeaways for recursion. Rule number 1, and you can't forget this, you must have a base case. If you don't, the method will just call itself forever, and you'll get a big, fat Stack Overflow error. Now, for some problems, recursion is way cleaner and easier to read than some crazy complicated loop. But you should also know it can be less efficient because of the overhead of all those method calls. It's a trade-off. Wow, okay, we have covered a ton of ground, and we've added some seriously powerful tools to your Java toolkit. Let's do a quick recap of how this all fits together.
So, when do you use which tool? Here's the big picture. Your go-to for pretty much everything should be standard methods and overloading. Use them to organize your code, make it reusable, and create really intuitive programs. But when you come across a problem that can be naturally broken down into smaller, self-similar pieces, like navigating a file directory or calculating a factorial, that's when you should reach for recursion.
So there you have it. You've got the fundamental building blocks and some pretty advanced techniques for writing cleaner, smarter, and way more powerful Java code. The only question left is, which problem are you going to solve first? Happy coding!